Hello everyone, I'm Zhaoyang Wang from Hebei University of Technology, Tianjin, China. Today I will briefly introduce our ECCV 2026 paper, FuDU, a fuzzy dual-dimensional uncertainty framework for streaming active learning in industrial defect detection. In industrial defect detection, deep models are usually trained from limited annotation data, but deployed in continuously changing production environments. This creates two risks. First, samples near the decision boundary may cause classification or localization ambiguity. Second, new domains or novel defects may appear as outliers. For high-stake inspection, especially nuclear field road defect detection, missing defect is much more serious than selecting a few extra samples for annotation. So a simple confidence-based active learning strategy is not enough. It can select many low-confidence predictions, but it is often missed false negatives because false negative may not produce any reliable detection box. Our idea is to evaluate uncertainty from two complementary perspectives: global uncertainty from the image feature space and defect uncertainty from the detection head. FuDU contains three main components. First is PGUQ, that is prototype-based global uncertainty quantification, which estimate global uncertainty using normal and defective feature prototypes. If an image is far from known prototypes, it may indicate domain shift or a potential false negative. Second is DEUE, which is Dual Entropy Defect Uncertainty Evaluator, which estimates defect level uncertainty from confidence, classification entropy, and localization entropy. And third, we use a fuzzy inference system to fuse these two uncertainties. Instead of using a hard threshold, FuDU maps uncertainty into interpretable actions such as do not sample, low frequency sample, high frequency sample, and must sample. This makes the sampling strategy more flexible and more consistent with the expert knowledge. Under nuclear field road defect detection datasets, FuDU achieves 96% MAP and 99.3 recall, while annotating only 15.4% of samples. Compared with confidence-based sampling, FuDU gives much stronger improvements because it can capture both false positives and false negatives. Compared with pool-based method, FuDU is more suitable for streaming inspections because it avoids heavy offline processing and keeps practical inference efficiency. We also validate FuDU across different backbone and detection heads, including swing transformer, VIT-DAT, DEIM, MR-DETER, and MI-DETER, where FuDU consistently outperforms confidence-based active learning. Overall, FuDU provides an expert-informed streaming active learning framework for reliable industrial defect detection, moving inspection system from passive updating toward active self-evolution. That's all my presentation. Thank you.